This is about the proxies. How many people over here are actually doing the stuff in Solidity, or Viper, or Yule, or something?
Would be good to understand the context of proxies.
5. So what? Who raised it?
I was saying, would be good to understand what proxies.
Yeah. Well, I will explain it here. So now I know better that it's needed to explain. This is one of the architectures of one of the projects which we did lately. We did this architecture together with Naim. That's the 4th person who actually established this meetup, and it solved a few things from the. I don't know. Can I move this? There is the external person here who interacts with the interfacing contract over here. The reason is that we wanted to provide like a really understandable interface on the Etherscan level for the persons who really want to interact directly with the contract. And which calls a proxy, that's the yellow one over here. The proxy is actually keeping so-called storage. So it's keeping the state of whatever that person is owning, because he is the owner of the proxy. And that proxy makes the delegate call into the like heavy contract, which like executes something which needs to be done across a different DeFi protocols. So that's basically where the things around here, those are like some supporting contracts and so on. It's not that important. Why we have chosen this is due to the fact that we didn't want to actually implement this proxy ourselves, this yellow one at that time. That was due to the audits, because we knew that the MakerDAO, the DS proxy from MakerDAO, that has been audited several times. It's quite proven because the whole DAI actually went through it. Do you guys know what's DAI? Who doesn't know DAI? Raise your hand, because that would be really.
Does or doesn't?
Huh?
Does or doesn't?
DAI. DAI.
What did you ask? Who does know?
Who doesn't know? Who doesn't know? Just to make sure. It's a USD stablecoin, right? So one of the biggest decentralized USD stablecoins, that's DAI, and that's actually when you use it or when it's being minted, it has to go through this MakerDAO proxy. So that's for several years that has been proven, this piece of code or piece of contract, which is actually deployed for every person there who literally prints those USD stablecoins. So we were like trying to reuse something which is already there on the blockchain. That's one thing which I would like to urge the rest of the coding people, not to reuse the code from the like templates or the libraries and to deploy it again, but rather to reuse the code which is already there on the blockchain, because otherwise we are blowing up the blockchain. Anyway, so this is the kind of the architecture, and what we will be talking about is this yellow piece of the code over here. And the problem which is there is that this proxy creation for the user is quite heavy on the gas. When you as the user, you want to create this proxy for yourself, because it's for each person, each user is a separate one. You spend almost or a little bit more than $500,000 of gas. Then you have times the gas price. So you might spend something like $30 US when the gas price is like 50 Gwei, I think, or even. Huh?
That is never the case, by the way.
That's what?
That's never the case. Like, it's usually more expensive.
Yeah, well, no, it's cheaper. It's a bear market, so it's good, it's cheaper. But I do remember that, when was the gas price like 150, which was quite common for quite some time in the past. You just spent like 5 times more. So even like 150, no, 3 times more. So $90 you spend, or $100 you spend just to create a proxy which would keep your storage, which would keep your assets basically. So that's really expensive. The question is whether we can do better. So we do have some requirements on that. And those requirements are, we would like to have a small bytecode footprint to save gas on deploy. We want to have some minimum gas for passing execution. So it means when the person really wants to use that proxy and do something, they pass the execution through the delegate code towards that heavy contract, which I mentioned before, towards the green one. And the other one, which is not that common among the contracts developers, is actually to try to really reveal target contract methods. That's, again, for the user to trying to avoid the blind signing. I don't know, are you guys familiar with the blind signing? Yeah, the auditor is. Yeah, the blind signing is that when you sign a transaction, even on the hardware wallet, you are literally do not know what you are signing, because there is something like a T, you know, you just see some bytes and you do not know what you are saying. But when you are signing a transaction, when the contract started, the dogma was that, or the axiom was that what you are signing, you know what you are signing, so you are then legally obliged, you know, and there is like even like a legal aspect to it, that you know what you are signing, so what you sign is final. And typically today, when you are interacting with the smart contracts, you literally do not know what you are signing. So that's the blind signing. And yeah, so those were like the requirements, and the second requirement was that we want to have this interaction over here through the proxy, which is doing the delegate call, and that does the call over here. Someone might ask the question, why don't we allow the user going directly interacting with the heavy contract? Typical reasons are upgradability. That's one of the reasons. What is there? The other, and this is the reason over here, is that those contracts over here, those DeFi protocols, they expect to return or assign the things towards the message sender. The message sender would then become the green one, and you do not want to keep that assets or those things, the results and the storage on the green one. You want to keep it for the user on his protocol, separated, isolated space, I would say. So that's the reason why this architecture. Does it make sense so far?
Maybe a few things to clarify. So you need this proxy in order to optimize the way user will get the information about the...
Yeah, can we get a quiet here with that? Thanks.
Yeah, I can repeat. So if I understood correctly, the main reason to have this proxy is to allocate some space inside the network to store some part of user data. For
that particular user.
Okay. And we need this proxy to basically to speed up the way user interacts with the system. So the user don't need to recover the state from the blockchain, but rather need to go to this specific proxy.
No, it's not about the speeding up. It's really about the isolation. It's about that fact that my assets do not mix with your assets.
Okay.
So it's about the isolation for that particular and every user.
Isolation, you mean physical isolation, or what kind of isolation you're talking?
Yeah, almost physical. Yeah, it's a little bit more complicated, but
yeah, I'm just trying to put all things together. So basically, does it mean that other users has no access to my proxy? Okay, so
exactly, it's your proxy.
It's encrypted, probably some sort of.
Yeah, you own the proxy. That's what you mean here. That there is like ownership of that.
Okay, so I can store some private data in this proxy, and it's under any circumstances it wouldn't be accessible by other users.
Yeah.
Okay, now it's clear.
That's that isolation.
Okay, cool.
And okay, so that's the architecture. What we wanted to achieve while saving the gas. And now then we go to the Ethereum standards. Is here anyone who doesn't know about the EIPs or Ethereum standards? Who does not know? Who knows about EIPs? Who was not waving hands? Ethan. Okay, we have 15 minutes left. So the point is that, you know, when I mentioned that the previous proxy was like almost 600,000 gas, that's really like significantly heavy. There is a standard for so-called minimal proxy. And a minimal proxy is described in this standard 1167. The great thing is that it's 45 bytes long. So deployment of those 45 bytes is like, I don't have that measure now right here, but instead of $30, what was the heavy one, this is like $7 or $5. It's really, or almost free. So like 10 times less. That's for the deployment. And so if the heavy one with the really high gas price is $100, this is like $10 instead. So you can see a significant saving here for the users. Typically it was used for the Uniswap version 1 for the AMM pools. Somehow and strangely, OpenZeppelin called them clones. I mentioned here the question, why do they call them clones? They call them for the reason that you have like a heavy contract, and they want to, that heavy contract, also including the storage, they want to like clone it for the other person. So instead of deploying that heavy contract, which would be also like 2 million gas, they just deploy this small clone, they call it clone, but literally it's proxy. And instead of 2 million, it's only like 70,000 or something like that, I think.
Can I ask, did they continue to use it for Uniswap V2 and V3?
I don't know. I don't know.
Because V1 is...
I don't know. I don't know. This is the bytecode. This is what you can see on the right side, and now the deep technical stuff. What that bytecode does, because it doesn't have a Solidity counterpart. You cannot write this optimization in Solidity. You have to write it in assembly or directly in the bytecode. So this is basically the parts of the bytecode. At the beginning, you receive some data, the request from the user. Then you forward that data to the implementation contract using so-called delegate call. Then you get the, whatever that contract does, so you get that result of that heavy contract, and then you return or revert towards the user. That's the logic there. This is the first part, so what you see...
So these are the steps that happens when I'm interacting or when I'm creating the...
Interacting. Yeah. You create it once, and then for every interaction, everything which you call towards that heavy contract, it goes through these 4 steps, and these are basically the steps, and this is underlined bytecode what is mentioned there. So first, if you read this bytecode, it doesn't make sense much, but you can even read it on the Etherscan and everywhere, and then. The beauty is that you have here one step. This is call data copy. So this means that it takes those arguments, what you are calling. That's these 1, 2, 3, 4 bytecode actions. Then actually you do the delegate call. That proxy does the delegate call to that heavy contract, which are these bytes. And this part, that BBBB, that's actually the address of the heavy contract. So this is just doing that bytecode. That address is mentioned over here, and then you get the result from that heavy contract, which are these 4 bytes over here, and you grab that. Then you need to decide whether there was some error, and you need to do revert, so reverting the transaction or doing the return, and that's actually this finish over here, and those are all those 45 bytes. So this is how to understand it, that basically using the bytecodes and the codes of the EVM, what it does, those are only 4 steps, and this is how it's implemented. You can see the link over here where it is explained. There are some optimizations for that. This is more minimal proxy, which for the deployment even eats less gas, even less gas for the call. Just to mention this one over here, this is standardized. This bytecode over this one, this is really a standard. This optimized one, this is non-standard, and there is no willingness to do it as the standard because it was too late. Then there is some extension, I would say. This already made as the standard. It's called meta proxy, which basically uses a similar approach like what we described before, but you can add any arbitrary data. So, for instance, my application deploys for you a proxy, this one, and adds some specific for you. And for you, it adds some other specifics as that arbitrary data, and that heavy contract which is being called afterwards can like reach those specifics and understand, it's you, or it's you, it's your specific data. And those data are stored in that deployment, and it's cheaper than do it like afterwards in the storage and so on. So this is like cool hack how to add something really specific for that particular person, but it's immutable afterwards. The only issue of these clones or these minimal proxies is that they have fixed target address. Something which we saw over here, this is the address where to call that heavy contract. Over here it was this one, that BBBB over here, that's the address where to call. And that's really an issue because it means that those heavy contracts, you do not have any upgradability on that. And in certain situations, you really want to have that upgradability. Or if you want to have that, you either need to ask all the people to actually redeploy their proxies and actually change and transfer the storage to their new proxies. Then you make a mistake, the users do not do it, and so on. So that's really hell. So you want rather to upgrade something more central, I would say. Even though we are trying to be decentralized, in these cases, decentralization might be like the better approach. How to centralize this? Well, first what we tried was like to chain those proxies. So we had like a very light one, that clone proxy, that 45 bytes, and then we chained like upgradability proxy behind it, and then there was the heavy contract. This actually created other issues. The issue was that chaining really failed in that method's visibility for the Etherscan and so on. So if you go to Etherscan, you can, on a certain contracts, you can, where there are proxies, you can say read as proxy or write as proxy, which means that it tries to reach towards that heavy contracts through that proxy and really read those methods and enabling you to interact with that heavy contracts through that proxy. This actually fails when you chain several proxies, one after each other. So that was a problem. So the conclusion is that we need a proxy with a mutable target address, effective one. So still keeping those requirements. And this is one of the ways how to do that. It's also standard. It's called the 1822. And this is the approach when you can like change the target address pointer within the storage of that proxy. It uses defined storage position. So there are like within the proxy there is like no implementation of the changing of that. You basically, of that logic of that heavy contract, you're like setting up the storage for that proxy. So you have to have that management aspect there, which says, look, you are pointing to me, but next time you need to point somewhere else. And this is called, or this storage position is defined in this way in order not to conflict with other storages which are there on the proxy. The disadvantages of that. The advantage. Look, what you can see here. I don't know. Do you know how to zoom it? It's like this, right? If we would compare it to those bytecodes which we saw before, this is actually the same approach what we saw before. There's a delegate call, then there is a return data and so on. First, there is a call data copy, meaning copying the parameters. So these steps are the same as in that very small one, 45 bytes proxy. These red underlined things are added. First, you need to load it from that storage. That's one thing. And then you need to apply that address which you get from here and use it for the delegate call. So there are a few bytecodes or operations added. So it eats a little bit more gas, but not significantly more. That's good. The disadvantage is that the delegated contract can literally kill your proxy, because you are pointing here, and if you do the mistake or there is some further delegation somewhere else, they can literally change the storage over here, and they could change this storage position, meaning that they can they can change the target to somewhere else without any meaningful targeting heavy contract, which kills that proxy afterwards and kills all the assets which are there. You will not be able to interact with that anymore.
And for all users as well. And for all users as well.
No. For that.
So you have
always for the particular user.
Okay, so every user has to like change the contract logic themselves, basically.
Yeah, that's another disadvantage over here, that when you do the upgrade of that heavy contract, the target has to be upgraded in each instance. So you need to ask that every user, please go ahead and do this interaction, or you bundle it with some other interaction when the user wants to do something, that actually the pointer towards the target heavy contract is changed. So that's disadvantage. The other approach is that the mutability you ensure outside of the proxy. One way how to do it is the Open Zeppelin standards. They have a beacon contract. That's a beacon proxy. This is a piece of code from that. If you had just used this beacon proxy and we tried it in the chaining, it's very heavy. The implementation, since it's like bundling these contracts over here and deriving from that, it's really for the deployment is heavy, so it doesn't pass the requirement for being light. However, overall the approach is quite good. Do you understand what a beacon is? No, not beacon chain. Beacon as the pattern.
Like signaling system.
Yeah. Basically, it's signaling. That's over here. This is the way how to do it. That you have the user that does the interaction with the proxy. The proxy calls the beacon, and beacon just emits back the information where is the target heavy contract. So you have like a center point with some DAO, management ways how to do that, and you just say, okay, it's not, the implementation what you want to execute is not here, it's somewhere else, and you do the change on one place over here, and every proxy interaction is just asking there, always. So that's the way how to do that. Basically, it can be done in a way that's similar to minimal proxy design, those 45 bytes code, and also similar to beacon proxy standard of the Open Zeppelin for this part over here. What are how it would look like? Basically, from the previous one which you mentioned, the only change would be here at the beginning. Instead of loading from the storage, we would need to make a call towards the beacon. That call is not expensive. I measured that. It's only like 2,500 gas. So for that kind of the flexibility, it's very cheap. Contrary to that regular, proxy designs of the Open Zeppelin and so on. Of course, you would not need to do the S-load, the storage loading. And the advantage which we mentioned, that beacon is centrally manageable. it means that you need to do just one transaction to do the upgrade for all the users simultaneously. The question and the strange thing is, most of the proxies which we talk today about, they are like, those implementations are like 3-4 years old. Even the standards, you can find them there like 2018, 2019, and so on. The strange thing is that this is not a standard yet. I really couldn't find it. I don't know why, because obviously the gas is being spent like heavily. So that's one thing. The other thing is we haven't tried it yet, so we are not sure whether Etherscan and so on they would be really passing those methods, to reveal them towards the end user. And the other thing is that we might have some answer over there. I do not know whether if we did it in the bytecode like that, whether that would be easy to pass the audits. Not sure. So that's it. We're at the end of 25 minutes. You might have a question on that.
Question. So you spent a huge amount of time on optimization of the contracts, and the question is, have you considered using some layer 2 solution like Optimism or Polygon or something like that?
Yeah.
To make it like way easier to call.
Yeah, we did. The point is, if you look at the architecture which we had here somewhere at the beginning, the problem is that some of the protocols which we want to interact with are only on the layer 1. And for instance, we have here the interaction with Liquidity, and the Liquidity is on the layer 1. Okay. And also the things which those positions or the assets which you want to keep towards that Liquidity, you want to keep it on the layer 1. Yeah. So, yeah. Otherwise, when you mention the layer 2 and when someone would mention the Polygon, so like a side chains, if you look at the spending of the gas, try to think what we experienced several years ago. At that time, gas was like 3 Gwei or something. I do remember in 2017, and it was in US dollars. It was very cheap. So we're like experiencing with something. What I did spend on the gas at that time, today has a value of several thousands of dollars. The expenditure of the gas of that time. So the same I really predict for the Polygon and the other like low cost, because everyone is wishing that Matic or anything else would really grow up in the value. It might be also the case for Solana if they are here. Once it will raise in the value several 100,000 times, you will see what was the gas expenditure there in the past.
Yeah.
Okay.
It's fun to look at old Etherscan transactions.
Yeah.
So you didn't still find the ideal solution for your problem?
No, well, I think the ideal solution is this one. And then there is a question is just to implement it and using that bytecode. You cannot implement it in the Solidity, that's what I mentioned. You have to use the UL assembly or literally bytecode, which is good. But then there are those questions regarding the audits. There were more questions. Yeah.
I actually have 2 questions. So number 1, so you make the proxy, but the proxy is mutable. Doesn't my guess is like that automatically makes a security risk, and it automatically makes like this signing where you authorize the owner of the centralized contract to modify your proxy.
It's actually not modifying the proxy with the beacon. You are just changing those central entity is just changing, or DAO basically. The one place where you are changing that target pointer. So you are not changing the proxy.
Okay, so that doesn't.
With this.
Okay, and that doesn't require like any special authorization or signing by the user.
So what?
That doesn't require like any authorization by user or like for user to sign something. You can go.
Exactly.
Okay.
You are the beacon. I am the proxy, and I'm always asking you: do I go there or do I go there? and you will always answer me, and what you answer me, there I go.
Okay, yeah, it makes sense.
Who has control over this beacon?
So what?
Who has control over this beacon?
It's up to how you design it. That's why there is a standard for the beacon proxy, and you have like a whole management, functions around that. So there is the like ownership of that beacon and so on. That's pretty common standard.
Yeah, typically it will be DAO, I would say.
Typically it's DAO, or some multisig at least.
So if you need a new version like Uniswap 3 or whatever, you can just upgrade and point it somewhere else, for example, and you don't have to force users to deploy new proxies that will cost them extra tokens, right? So that's the advantage of like...
Yeah, that's the main idea. Yeah.
Yeah.
I got it. Yeah, I got it.
Yeah. What about the audit? How do you look at that?
What about auditing? No, I mean, most audit firms won't give you a problem with audit assembly. Like, if the problem isn't necessarily auditing assembly, it's just like probably there's just no EIP because like
Yeah.
for EIPs, like the main thing is that you have like someone who's actually pushing through and like doing the process.
So there's like a peer review, right? When there is the EIP.
Most people think it's a huge pain in the ass. So like a lot of people will just develop the code before actually making it like a standard, especially these days. So like the reason that, I mean, I'm sure something like if this is in production code, it's been audited, but like for an auditor, like you would have to have like the team like write off like, hey, this has been audited, like this implementation has been audited by someone else, or it's been audited in this other audit. So just like assume that it works. So don't end up in the scope, because otherwise, like, yeah, you don't want to be putting in like code like this into like every new audit, because it gets re-audited. It's a huge waste of money. So what you need is basically someone to like, so you just need one person to pay for an audit from like a reputable firm and be like, hey, it's audited. And then like the auditors, like if you just tell them it's out of scope, they won't look at it.
Yeah.
Yeah. So that's why there's no.
Just move it up.
Okay, there was someone else. Yeah, raising the question.
Just me again.
Yeah.
The other question, so it's about bytecode. So you said that you cannot write it in Solidity, so you can either write it in assembly or directly in bytecode, which is like super weird for me. Like I worked with bytecode before, and especially Apple, they use it like super heavily. And actually, if you look at Swift, like it's compiled like to bytecode like one by one. You can take Swift and make bytecode and then make binaries directly, or you can take bytecode and make Swift. You can even, like, for example, Apple did it when they changed the architecture of watchOS, like when they changed like to 64-bit. They actually took the bytecode of all the apps in the App Store and they injected the new architecture in the bytecode and then recompiled bytecode into binary and redeployed the update of all the apps like on the App Store without actually doing anything. So like it's like super weird for me like to hear that Solidity cannot go to bytecode.
No. That's actually a Solidity snippet. That's like an assembly snippet within Solidity. The problem with writing this in Solidity isn't that it can't be done. Absolutely can be done. It just can't be done with these gas advantages. Like you can't like optimize every single bytecode in Solidity because you got like the compiler like step, right? It's doing the optimization for you. So if you want to write like the most optimized smart contract ever, then you have to do it in like this assembly snippets or just like UL or like just straight assembly.
Oh, okay, that makes sense.
So it's like it's possible. It's just it would cost like Solidity compiler would add more instructions than are necessary, so it'll end up like costing more. That's why we're talking about minimal proxies.
Yeah.
Okay, that makes sense completely. Thanks.
Okay. We done? So thanks. If you would have more questions, I would like to talk more about that and the bytecode. Let's just chat after our other presentations or about that. I would really appreciate it because I've been thinking about trying to pushing it out as the standard. So that would be more like peer-reviewed and more accessible or more for the auditors, more not accountable. I cannot find a word now, but
Next generation minimal proxy standard, basically.
Yeah.
Well, I try to call it like minimal beacon proxies. That it's just using the beacon.
Yeah, I would try to get it into something like OpenZeppelin if it's possible. Like have you tried like opening up?
No, I haven't tried it because I was still researching whether there might be some solutions on that. And these are all I found. Even though I found a few more, but they were like literally having like 700,000 gas, you know, just for. And some of the construction which you could see in the solutions when you have like 8 proxies doing some things, or the diamonds. You might be aware of the diamonds. That very, very heavy. You know, so and I think we need to go with the blockchain development, since those are immutable deployments. We need to try to optimize more and finding the solutions which are more optimized. Okay, thanks a lot, and let's have a short break, and then we will have our next speech, right?